Alright, hello everyone. My name is Asafa Mashasha. Today is December 28th, 2022. Alright. Okay, so I have a video presentation for University of New England Biochemistry Fall 2022 class. I'll be presenting two patient case scenarios here. The first question is, or the first case is about a 16-year-old female which is recently diagnosed with a deficiency of muscle glycogen phosphorylase. So I'm not gonna read the whole patient case. I'll just go ahead and start with the first question here. So the first question is asking about, I'm not sure I understand the issue. Can you explain how muscle glycogen is used normally to exercise? So all right, to answer this, so we have to start with the blood sugar. The blood sugar is, or glucose is the main sugar found in your blood for energy, right? And glycogen is a stored form of glucose. So the function of muscle glycogen is to serve as an immediate source of glucose for the muscle. So when we perform when we perform certain exercise or activities, this muscle glycogen is going to be transformed to glucose 6-phosphate, not into glucose. Right? That's because of the lack of the enzyme. The lack of enzyme that was mentioned. Glucose 6-phosphate is. So skeletal muscle uses glucose 6-phosphate as an energy source during activity or anything, whenever we do anything to produce energy, which is the energy is called ATP, adenosine triphosphate molecules, which this energy is required for the contraction of muscle during exercise. Okay. Next question. I really like to take a long walk. Long walks, will I still be able to do this with my friends? Alright, so let me explain this. Your body lacks muscle glycogen phosphorylase. So this causes the called McArdle disease, which is a rare genetic muscle disorder, and is characterized by not being able to utilize glycogen for energy. So under this condition, it makes you feel like very tired, or like you have muscle pain or stiffness during exercise, or walking, or during any activity. Most patients with this disease, they lose the ability to walk due to weakness and muscle loss. So unfortunately, you will not be able to walk or go for a long walk with your friends. Next question is, as a result of this deficiency, will I need to get up at night to eat to maintain my blood glucose level? Basically, the short answer would be no. It is not necessary to wake up at night to maintain to eat at night and eat to maintain your blood sugar level. So your glucose intake needs to be, but your glucose intake needs to be higher, so that you can have enough energy performance for certain things. So it's always best to get an advice from your doctor about your diet, and also pay attention for having appropriate amount of carbohydrates, so that you have enough glucose in your body to have enough glucose in your blood, and also energy. If a person have not eaten for a while, because of the disease condition, the glucose level in the blood will start to drop, and the body would start to using some of the glycogen in the glycogen in the muscle. Okay, number 4. Do I need to worry about producing excessive lactate during intense aerobic exercise or anaerobic exercise? So lactate, when we do anaerobic exercise, of course, lactate will be produced from our, from blood glucose. What happens is the glucose in the blood is converted to lactate because it's a process that goes through without oxygen. So that's why we produce lactate, and the lactate it gets accumulated in the muscle, and the muscle gets very fatigued. That's why every time we work out, we feel like muscle fatigue. That's what it is, accumulation of lactate. So for you, since you have blocked muscle glycogen breakdown, you have a severely reduced capacity to work out as compared to healthy individual. So you are not assumed to produce lactate during exercise. And if your body produce lactate, um, it might not be appropriate for your body. Okay. So the second case is case 3 about the 5-year-old boy, which was brought to the pediatrician office for annual visit. Let's start and present the first question. So what is this information likely to suggest about the underlying biomedical basis for the patient's symptom? So according to the child's lab report, baseline blood samples of the child, it's 0.8, which is less or very less compared to the normal value given above 6 plus or minus 2. With 1 hour after glucose load is given her child having serum insulin level of 5, which is again low, very low compared to the normal 40 plus or minus 11. So the underlying biochemical cause for the patient's symptom is hyperglycemia. Hyperglycemia, this indicates that the patient's body cells are not able to effectively absorb the free glucose molecules from the bloodstream because of decreased insulin hormone in the body or in the blood. Factors contributing to this or contributing to hyperglycemia include reduced insulin secretions, decreased glucose utilization, and increased glucose production. So glucose homeostasis is a balance between hepatic glucose production and peripheral glucose uptake and utilization. So in this case, insulin is the most important regulator of glucose homeostasis. Okay. Next question. What would you predict the patient for fast blood glucose level to be given his current condition? As the hormone insulin is insufficiently present to undertake its normal functions, which is to assist body cells in absorbing glucose from the blood, the patient fast blood glucose level would be over the normal range, which is straightforward. And number 3, based on this diagnosis, what 2 regulatory enzymes are likely to be active in this individual? So we are aware that the main energy source in our body is glucose. However, in this instance, since the cells are unable to take up glucose from the blood, they are unable to use glucose as a fuel source. So they would now obtain energy by mobilizing fat. In such a scenario, hormone-sensitive lipase, which starts the breakdown of lipids to provide energy for our body, right? And also glycogen, which can increase lipolysis-inducing enzymes, would both be active regulatory enzymes. So both enzymes, lipase and lipolysis inducing enzymes. All right, that should be it.